In this video, we'll be graphing a piecewise-defined function. And a piecewise-defined function works like this. You first look here. That is, you look in this column. So if x is, for example, if x is less than -2, then we are going to evaluate the function as 4x plus 11. So if you plugged in -5, for example, you would plug in 4 times -5 plus 11. And that would be the way to evaluate the function. If x were in between -2 and 1, then you would just say the function is equal to 3. That's it. So if x was 0, the function will just be 3. And if x is greater than 1, let's say you're plugging in +5, then you would say -1/2 times 5 plus 7/2. And you wouldn't worry about any of the other pieces. So that's why it's called piecewise-defined function. Sometimes graphing it helps to visualize what's happening. So let's graph first this 4x plus 11. Okay, so what we have is this graph in red. Notice that I have a dashed line here, and that is because when x is less than -2 is the only time that this part of the function, this piece of the function is used. So that's just down here. So if this is -2 right here, so anything to the left of that, then we use that piece, 4x plus 11. Anything to the right of that, we're not really graphing. So I just put that dashed line in to show that 4x plus 11, but we're not really graphing that whole thing. So we'll turn that off. Now I'm going to graph this part, the time when x is between -2 and 1. And that is the function just equals 3. So when x is between -2 and +1, then the function is just 3. Okay, and I could go to the left and to the right of that with the dashed lines and everything, but I'm not going to do that here on this one. We just have from x is -2 to 1. Now, what about this part? If x is greater than 1, then we're going to graph this line, -1/2 x plus 7/2. So this is what the completed graph looks like, and in green I have the last piece graphed. So anytime x is greater than 1, we're going to evaluate the function as -1/2 x plus 7/2. And I've got that graphically shown here. Now again, we can graph the whole lines, the 4x plus 11 and -1/2 x plus 7/2, but we're not using that because what's in red is only valid when x is less than -2, and what's in green is only valid when x is greater than 1, so to the right of when x is 1. And so we'll turn that back off. And then of course the blue, that's a little bit easier to see. The function is just 3. That's it. It's kind of weird to think about, but the function is just 3. So if x equals 0, then the function is evaluated as 3. And when x equals -2, because it's including -2, then the function just equals 3. Now, one thing to note here. Here I've got the dots on the blue, these closed circles, and that is because we're including 1 and -2 in that piece of the function. So that's why it's not a green closed dot or a red closed dot or point. Also, these things will not always line up exactly on the same point. You might have a jump up there, so you might just be going along and then boom, instead of the green starting where it did, you might start here and go on down. All right, this function didn't, but you might see that. So just to let you know, they don't always line up exactly in the same point. Okay, well I hope that helps. And just remember, you take the x that is given, so f of 5, f of 3, f of whatever, see what condition it meets. So if it meets piece 1, then evaluate at piece 1. If it meets piece 2, evaluate at the piece 2. If it meets the third piece, if x is greater than 1 in this case, then evaluate using that third piece.